Good morning. This is James Taylor from Swayslock, Georgia, Jacksonville, and South Carolina. Today we are hosting Kelly Paffel from Envino Engineering. Kelly is going to talk about our steam sampling systems. Kelly, go ahead and take it away.
All right, thank you, James. Let me get my share screen.
And as we get started, please feel free to ask questions. I will go ahead and relay them to Kelly, and we will answer as we go.
So, James, you see the presentation?
Yes, sir.
James, can you see the presentation?
Yes, sir.
Okay, very good. Good morning, everyone. Today I want to talk about steam sampling systems. Every boiler plant needs a steam sampling system. Let me get this. 96% of the steam sampling system is conducted in the steam generation area, called the boiler plant. As shown here in this picture is a standard boiler plant. And it can be a very small boiler plant. I mean, just simple as a water processing plant, which is a very small steam plant, to a very large plant. And in the steam sampling system, we're looking at boiler chemistry, deaerator operation. But outside the boiler plant, there are other areas that we do need steam sampling, which I'll go through. Every steam generation area or boiler plant requires testing for boiler chemistry, as I was talking about, boiler water quality, boiler carryover. One of the things that's not measured and should be measured is for carryover. Of course, condensate corrosion is a big factor in the steam and condensate system. And we need to be doing testing in strategic locations. Now, as is shown here, this is a very chemical processing plant, and they'll have steam generation units, heat recovery units, sitting out into the process area itself. So not only in the boiler plant or utility plant itself, there are sampling systems out in the facility itself if we are generating steam from heat recovery systems. Testing, daily testing is typically the best practice. I mean, again, down to the very small systems, to the large systems, sometimes in the larger systems, we're testing twice a day and possibly 3 times a day. So that's a standard international best practice. Safety is always a #1 priority when conducting testing. I'll be talking about safety and the code requirements when it comes to testing. Remember one thing, in steam systems, we are underneath the B31.1 National Power Piping Code, and we need to be following the code. Sample preparation is critical. It depends on the chemical supplier, what temperature they want the sample at. And reliability in the system is a necessity. Typical requirements, yeah, we're looking for pH, going to the boiler, and pH in the condensate coming back from the boiler, conductivity, hardness, OH, alkalinity, and sulfite. And there may be other measurements that the chemical supplier may be asking you for. Now, shown in the picture on the right-hand side is what we call the older method, which means this is, the older way we did it, a threaded pipe, single sample station. As you can see already, leakage is occurring, and this is not that old of a system. Other requirements for measurement, it could be phosphate, deaerator dissolved oxygen per ASME testing standards. A big thing is with the deaerator testing for dissolved oxygen. Unfortunately, probably 70% of the plants are not doing it, and they need to be doing it. It's one of the things that we deal with in the steam system is corrosion, and we need to know the deaerator is removing the dissolved oxygen or the other non-condensable gases per ASME. Other tests, as I said before, depends on the chemical vendor and their recommendations. In a typical steam system, and this is a typical steam system, is, one of the things what we want is number one, a central location. We don't want the plant personnel running around to all these different locations and taking samples and carrying the samples back to a central location to do the test. We don't go out and do the tests out there in the field. We're bringing the samples back to an area, lab, whatever you want to call it, and doing the testing there. So number one priority, of course, is to have a central location. First thing we want to do is take a measurement of the water quality coming in from the plant. I mean, we have different water sources that we use, well water, city water. Sometimes we're taking river water in, preparing it through sand filtrations before we hit the water preparation equipment for the boilers. The next sample is, of course, we want to know how the water softeners, dealkalizers, RO systems performing before we go into the deaerator operation. So that's another sample point. Oh, excuse me, too many clicks. Apologize for that. Next thing is that we're taking a sample off the deaerator system, typically downstream of the feed pumps, prior going into the boiler operation. That there is we're looking at sulfite residual or the remaining oxygen in the feed water system. The other thing, once some plants, not all the time, that they're taking a sample after the economizer heat recovery system. Some plants prefer doing that, other plants don't. It's just another sample point. One of the biggest sampling areas is off of the drum or boiler itself on the water side. There is critical because we're looking at TDS or total dissolved solids, and we're controlling our blowdown regarding that measurement. So we could be looking at alkalinity and pH as other measurements there, but that's probably one of the biggest measurements is right there. The next measurement is on the steam header. There we're looking for boiler carryover. One of the things that causes issue in the steam system is boiler carryover, and not to get into all the things that cause carryover, but it's another critical measurement. And the last measurement down here is for condensate return. There we're trying to measure for pH that's coming back in the system in the condensate. So now is the systems, we have multiple boilers. Of course, we have multiple sample points. So the systems can grow in size. So it depends on the operation. This here, we have a steam turbine and we're looking at the condenser. We have multiple condensate returns that we have to look at. We have multiple boilers that we have to take measurements off the boiler. And we possibly could have multiple steam headers, which are taking measurements. So the systems can grow in size depending on the boiler operation. Preparing the sample for online continuous monitoring. So we have continuous monitoring system, and one point is the deaerator, and we're measuring for dissolved oxygen 7 parts per billion. And we have to prepare the sample for the measurement unit itself. Other measurements were taken off the drums. We're looking for connectivity. So there's also preparing the samples for continuous monitoring in the steam or boiler operation. Steam sampling negatives with the standard steam systems. Probably number one is code violations. Okay, you find that all the time. Leakage, internal valve leakage, non-standard operating procedures, testing procedures not posted, and improper labeling. So as you can see in this picture here is these ball valves for isolation. They're in code violation. They're not rated for the maximum pressure and temperature, which we unfortunately find all the time in the system. Steam sampling systems, all valving components, sampling chamber, tubing, all has to be rated for the maximum pressure and temperature, and that's the boiler safety valve typically on the boiler safety valve. So code violations are the big one. Leakage because people use, threaded connections, and threaded connections, always are the number one source of leakage in the system. So going into a sampling system, we're always dealing with leakage. How to get rid of leakage? Don't thread pipe. Simple as that. If you stop threading pipe, you don't have steam leaks or condensate leakage in the steam and condensate system. Internal valve leakage, all valves have to be rated to FCI standards or API standards. And we buy these valves, and again, this is a typical ball valve you'll see in the system, and it doesn't meet any internal leakage standard, and they leak through. So on sampling systems, we cannot have valves leaking through because it causes issues and possibly even shutting down the boiler itself so we can fix the internal valve leakage. And the other things are no standard procedures or testing procedures are not posted in labeling. So on the left-hand side, as you can see, these systems can grow in size, okay? So this is a cogeneration unit. But as you can see, the sample chambers on the left-hand side and the two on the right-hand side, these two sample chambers do not meet code, okay? They're in code violation. So understanding the codes when you're putting these systems together and meeting the codes is a necessity, okay? It's for plant safety. You have to have every component meeting the code requirement B31.1. The right-hand picture, again, standard ball valves, again, in code violation. And why I bring this up is, probably 90% of the plants I go into, I'm finding code violations with valves. You have to have pressure ratings for the maximum pressure and temperature. Again, simple sampling system, central location, correct valves for positive shutoff. Okay, valves have to shut off. The valve has to be purchased for internal leakage as per FCI or API, and when you're purchasing valves, you have to specify that. The other thing is two valve protection. Okay, so on this sampling system here, you can see we have two valve arrangement prior to the sample chamber. Sample has to be cooled down to 90 degrees F. It depends on the sample we're taking. Some people have 80 degrees F. Some people have 100 degrees F. Sample flow throttle at the outlet of the cooler only, and discharging the sample to a safe location. And there's a multitude of different configurations of the central sampling system to achieve proper sampling and safe. Now, other sample areas that we look out there, we can have rotating dryers, process coils, and reboilers. And out there, alongside this equipment, again, we can have sample chambers sitting out there and allowing us to take samples out there in the system and, proper preparing the sample, bringing it back to a central location. Plant condensate tanks, of course, we want to look at the condensate system out there, specifically on pH level, to make sure we don't have corrosion, CO2 corrosion going on. The other thing is contamination. A lot of times we're dealing with condensate coming back from processes, and we need to be looking for contamination. The smaller picture here is a standard, again, system out there. Again, lots of threaded connections and always leakage points. Understanding the different items, codes, ASME, the boiler codes, the ASME pressure vessel, B31.1, possibly B31.3, and there's 31.9, B1634. So there could be multiple codes coming into play when we put these sample systems. Then there's also code recommendations, which are not code, but need to be recognized because it's the code says B31.1, there's code items, and then there's recommendations. Might as well take the recommendation, say the code, because they're recommending us to do it the correct way. Then we have industrial best practices, and we need to follow the best practices to ensure reliability and optimal performance. So we can have a valve that meets all the code requirements and has terrible reliability. I mean, failure within 1 year. So industrial best practices tells us how to do the system correctly, specify the correct components to get reliability, optimal performance. So these are all the things that we have to look at when we're putting in a sampling system. Just a tidbit, B31.1 is a power piping code. It's followed by all countries. You know, in Colombia, South America, they follow B31.1. And in Thailand, they follow B31.3. They're both similar. It's just making sure that you are following some code. And then again, B16 is used for process valves, such as ball valve rating, materials design, wall thickness, and 31.9, which doesn't come too much in sampling systems, compressed air, but just to give you an example of all the different codes that we need to follow. Now, out there in the system, there are different pressures in the system, and understanding the different pressures. So if I'm going out here and sampling into this process system down here, there's a pressure reducing valve reducing the pressure, and there's a safety valve behind it protecting the system. So when we're putting in a sampling system there, we have to know the safety valve set pressure, because then we have to design to the safety pressure. Remember one thing, all sampling systems, we are not designing for operating pressure. We're always designing for maximum pressure and temperature. It's dictated by the safety valve that's protecting the system. It's not uncommon for plants to have multiple pressures. So understanding that we're looking at not operating pressure, but maximum design pressures and temperatures in the system. So what materials are used in the steams in the system for bringing sample? Yes, carbon steel, stainless steel alloys. In piping, you know, again, we're going back. If you're going to use pipe, welding is the number one preference in connections. Tubing, you know, carbon steel, stainless steel alloys. And I'll talk a little bit about support, which is in this picture here on the left-hand side. It's not very well supported, okay? But it's coming back to a central location. All tubing and piping needs to be properly supported, and that's in the code. You know, it tells us, you know, we have to properly support. As you can see, this is not properly supported. The other factor with the sampling system is you got to take in consideration expansion and contraction, which is always not done. So the tubing here is going to expand, okay? It's going to expand in multiple inches, okay? So we have to, you know, design for the expansion and contraction of the tubing. So in our design, depending on the length of the tubing and the temperatures, we're designing in there for the expansion and contraction. So we do support the pipe or the tubing, and we guide the tubing, but we do not anchor the tubing. So the tubing is not fixed or anchored. Other factors, weight of the fluid and weight of the pipe and tubing. So when we look at sports, you know, is it going to be a liquid filled, vapor filled? So we have to put that into our calculations for how many numbers of supports that we need for the tubing. Tubing versus pipe, just remember ODID wall thicknesses. You know, when we go into wall thicknesses for schedule 40/80, you know, it's common, so we know what the wall thicknesses are and the pressure and temperature rating. And the same thing with tubing is we can use 0.035, 0.049, or 0.065, or 0.109. We have to know the maximum pressure and temperature, which dictates the wall thickness of the tube. The other thing is out there in the performance is knowing the steam pressures in the system. So pressure gauges are critical in all parts of the system, even in the sampling system, so we know the pressures that are coming down into the system. We want to know that, so we know that we do have insignificant pressure drops in the tubing coming to the sampling system. So,
Kelly, we do have our first question.
Yeah, go ahead.
This is Ifan from Indonesia. Why is welding preferred connection When it comes to superheated steam at 650C, what is the best connections? Will Swagelok tube fittings work in this application?
Well, there's three ways of doing connections: welding, flanges, or tube connectors. Okay. So the thing is that the higher pressures, temperatures, or even low pressures, temperatures, welding is preferred. So, you go into a plant operation, how many welds do you see leaking? Zero. Okay. It better not be leaking. Okay. For one thing is that the code requirements uh, for these systems are, you have to have a welder that is code certified, so he can do the weld. So you're getting a person that's very proficient at welding. Weld points do not leak. Okay. So there's no leakage there. So next thing is flanges. People say their flanges leak. Flanges do not leak, but flanges today, you have to know the torque spec and the torque pattern. And flanges only take up axial movement. They don't take up any other movement but axial. And what happens is when we're looking at flanges, there's movement besides axial, and the flange will leak. Now, tube connectors is the third method that we prefer. And we use tube connectors all the time. It's a easy method to make the connection. They're guaranteed not to leak if the people are trained properly when they're putting it in. So there's no issues with it. So you have three choices. Now, when it comes to sampling systems, tube connectors are the preferred method. Welding is probably number two, and we never typically use flanges. The last method is threaded connections. Never use threaded connections. You ask 10 people how to put threaded connections in, you get three different answers. You ask 20 people how to put threaded connections, and you get 20 different answers. So the other thing is that in these sampling systems, you're going to have expansion and contraction. Tube connectors, welding, take up, the expansion and contraction without an issue. Threaded connections are not very tolerant of expansion and contraction. It always could, causes issues with that. So those are the methods. So does that help?
Thank you, Kelly. I'll let you know.
Okay. So, but anyway, installation considerations, the thing is that as you can see in this tubing installation, the loops are there for the expansion and contraction. Now, the sample chambers down here, they are classified, underneath B31.1 or pressure vessel, ASME pressure vessel code. So it's understanding if they have to be B31.1 or ASME pressure vessel. And it depends on how much volume of steam is contained in the area, how your configuration. Most of the time it's B31.1. So, but anyway. And then in the right-hand side is a tube within a tube. So when you get a very high pressures, and we're talking 3,200 PSI, because of the sample chambers being so robust for that pressure and temperature, typically they'll go to a tube within a tube for the cooling process. So just to conclude, the sampling system, we're looking at safety, of course, is number one priority. Probably the biggest thing is making sure that all components are meeting code requirements. And I can't stress that enough as I go in on these sampling systems. If I look at 30 of them, maybe only 2 are in code compliance. The rest are not code compliant. So having code, everything done to code is very important. Installation savings. Yes, welding costs me more to do. Tube connectors save me the weld time, and it's just as reliable as welding. So those are some of the things that we look at. And tubing is much easier to put in than threaded pipe, And people say, oh, threaded pipe is cheaper. No, it's not. If you look at the time putting it together, correcting the leakage is not. operational savings are there, that I don't have the failures to correct. Highest reliability. Again, with these valves, we are taking high pressures. And we could be doing 400 psi, 900 psi, even 250 psi. We're opening a valve to the sampling system, and we're taking a huge pressure drop across it. So in the higher pressure systems, we're using multiple valves or a valve with multiple orifices behind it to step the pressures down. That gives us reliability. So just remember, if you're taking a pressure drop greater than 50% of the inlet pressure, the valve will go critical, and we need to stop the valve from going critical. And one of the biggest things in utility operations or boiler operation, people complain about steam sampling valves leaking. For one thing is you're buying a valve that already leaks, okay? So you have the problem to begin with brand new out of the box. So understanding the internal leak rates is very important. The second thing is putting the valve in that will take the pressure drop that we're looking at. So many times I'm working with these, we're taking pressures of 900 psi going down to 0 psi. The valve goes critical, so we have to do certain things to stop the valve going critical. If we do that, the valve gives us long life and it's very reliable. And the other thing is easy testing solution. Central location is a must. Going out with single sample stations out there just is horrible. Plant personnel get tired of running around with samples and stuff. So, and then my last statement: how did we get started on Monday? So, questions.
We'll now open the floor up to questions. If you have a question, you can either unmute or go into the Q&A and type in your question. Nothing so far, Kelly.
All right. If you have any questions, just contact your local Swagelok person, and they can get a hold of me and be more than happy to discuss any of your questions.
Excellent.
All right.
Oh,
very
we
good.
did have one. Hold on one second. We did win another question in from Infranova. This is ASME PTC 1911 about SWAS SWAS. Why is regulator not allowed to be used?
What's SWAS? I don't know what that is. I'd have to look up to see what SWAS is. A regulator is not allowed to be used. A regulator is nothing but a valve. So I don't know. I would have to look it up and get back to you.
Sampling water
Sampling
analyzer
water
system.
analysis system in a power plant.
Gotcha.
We do use regulators and water analyzing systems in a power plant. I'd have to look up ASME PTC 1.19.11 to see specifically why. I mean, water and analyzing in a power plant, regulators are commonly used. So I don't know why it's not per this code. I'd have to look up the code to get back to you, which I will do. Anything else? All right. Very good. Have a great day.
Thank you, Kelly. Hope everybody enjoyed it. Y'all have a great week.